Good morning, friends. Today we discuss about the one of the well-known principle, that is the Heisenberg uncertainty principle. This is a very well-known uncertainty principle. That is, according to the Heisenberg uncertainty, that is according to Heisenberg scientists, they have invented the exact position and the momentum of the particle. We cannot calculate the exact position and the velocity of the particle. That is what they have discussed regarding about this uncertainty principle. Today we discuss about this principle. So the according to the Heisenberg scientist, the dual nature of an electron means that the any precise measurement of its position would create some uncertainty in the measurement of its momentum and vice versa. And this was pointed out there pointed out by the Heisenberg in his uncertainty principle. According to this principle, it is not possible to determine the precisely both the position and the momentum or the velocity of an moving particle. This is the statement of the Heisenberg uncertainty principle. That is, we cannot calculate or to determine precisely both exact position and the momentum or the velocity of a moving particle. According to him, and the Heisenberg scientists have expressed one formula, that is the delta x into delta p is equal to the h by 2 pi. Delta x, what is meant by delta x? That is, the delta x is the uncertainty with regards to the position position of the particle, and the p is the uncertainty with regards to the momentum of the particle. Then if the delta x is very small, that is, if the delta x is the very small, then the that is, the position of the particle is known more or less exactly, and delta p would be the large. Delta p, that is, it means that the momentum of the particle or the velocity of the particle, that is, uncertainty with regards to the momentum will be large. Similarly, if an attempt it is made to measure exact velocity or the momentum of the particle and the position of the particle, uncertainty with regards to the position become larger. That is, at exact point we cannot determine the exact position and the momentum or the velocity of the moving electronic particles. Then the physical concept of uncertainty principle, that is, may become clear when it is realized that all observations have to be made by impact of light radiations, that is, the photons is equal to h nu, that is, the photons. If the object is reasonable size, its position or the velocity will not be altered by impact of light photons. Hence, it will possible to know precisely both position and the velocity of the object. velocity of the object or the electrons. In other words, the uncertainty delta x or the delta p would be negligible. Negligible, it means that the value will be very very small, but this cannot be shown. This cannot be. So when the object is extremely minute, that is the, if the object is very minute, it means that which is cannot be seen by naked eye, that is the electrons, such as an electrons, moving electrons, say in circular path, it will suffer a change in its velocity and the path due to the impact of even a single photon of light used to absorb it. So this is the sorry. So this is the uncertainty, Heisenberg's uncertainty principle, and this principle, according to the scientist, that is, we cannot determine the precisely both the exact position and the momentum or the velocity of a moving particle. That is, particles are, suppose the electrons having the very negligible particle, very very minute particle which cannot be seen by naked eye. That's why, and we cannot precisely calculate or determine the exact position of the electron and the momentum or the velocity of the moving particle, and they have invented some mathematically expressed one formula, that is the delta x and into delta p is equal to h by 2 pi. So this is the delta x is the represented by the position and delta p is represented by the momentum or the velocity of the moving electrons. So this is the Heisenberg uncertainty principle.